If you've ever tried to group anagrams in code, you've probably made at least one of these three mistakes: using brute force, ignoring edge cases, or overcomplicating the key. Today, I'll show you the clean, efficient way to solve this problem in just a few lines of Python. By the end, you'll master the right mental model and write code that handles any input like a pro. An anagram is a word formed by rearranging letters of another, like eat and tea. The problem asks us to take a list of words and group all anagrams together. For example, given eat, tea, tan, ate, gnat, bat, the output should be groups like eat, tea, ate, tan, gnat, bat. The challenge is to do this efficiently without comparing every word to every other word. Here's the intuition: anagrams have the same letters in a different order. So, if we sort the letters of each word, we get a unique key for all anagrams. For example, eat and tea both sort to aet. We'll use this key to group words in a dictionary, then return the groups as a list. This approach avoids the O, N superscript 2, brute force solution and keeps things simple and fast. First, we import defaultdict from the collections module. This is a special dictionary that automatically creates a default value when we access a key that doesn't exist. We'll use it to avoid checking if a key exists before appending to its list. Without this, we'd have to write extra code to initialize each key's list, which would clutter our solution. We define our function group_anagrams and initialize groups as a defaultdict of lists. This dictionary will map our sorted letter keys to lists of words that share those keys. The defaultdict ensures that when we try to append to a key that doesn't exist, it automatically starts with an empty list. This is cleaner than using a regular dictionary and checking for key existence every time. For each word in the input list, we create a key by sorting its letters and joining them into a string. This sorted string is the same for all anagrams of the word. For example, tea becomes aet, matching eat and ate. This key is what allows us to group anagrams efficiently. Without sorting, we'd have no way to identify which words are anagrams of each other. We use the sorted key to append the original word to the corresponding list in our groups dictionary. The defaultdict handles the case where the key doesn't exist yet, so we don't need any extra checks. This line is the core of our solution. It efficiently groups words by their anagram key in a single pass through the list. Finally, we convert the dictionary values into a list and return it. This gives us the grouped anagrams in the format we want. The list, groups.values, call extracts just the groups of words, ignoring the keys we used internally. Without this conversion, we'd return a dictionary, which isn't the expected output format. In the main block, we define our test input, a list of words including several anagrams. We call our function and print the result. This is where we verify that our code works as expected. The test case includes words like eat, tea, and ate to ensure they're grouped together, and bat to check that non-anagrams stay separate. When we run the code, we get exactly what we expected: a list of grouped anagrams. The first group contains eat, tea, and ate, the second has tan and gnat, and bat is alone. This output proves our solution works correctly and efficiently for the given input. Let's talk complexity. The time complexity is O, n asterisk k log k, where n is the number of words and k is the maximum length of a word. This comes from sorting each word's letters, which is the most expensive operation. The space complexity is O, n asterisk k, to store all the words in the groups. This is optimal for this approach. We can't do better than O, n, space because we need to store all the words, and the sorting step is unavoidable for creating the keys. The key insight here is that anagrams produce the same sorted string. This transforms the problem from comparing every word to every other word into a simple dictionary grouping. Remember this mental model: sort the letters, use the result as a key, and group words by that key. It's simple, efficient, and works for any input. Now it's your turn. Open your editor, type out this code, and test it with your own list of words. Experiment with edge cases like empty strings or words with special characters. Once you've mastered this, you'll never struggle with anagram grouping again. See you in the next tutorial. This video is powered by Crack Interview AI. It shows you live answers during real interviews. Try it free at crackinterviewa.in.